So today we are going to be learning about physical and chemical changes. This is just an overview. Physical changes are changes of state that have no composition of matter. There are several examples that you might be familiar with: crushing a can, dissolving sugar in water, shredding paper, boiling water, chopping wood, creating a mixture, melting an ice cube. The main thing is that the composition of matter does not change. Those intramolecular bonds do not change. On the other hand, a chemical change is where you take one or more materials, you break the intramolecular bonds and you form new intramolecular bonds. A new material is formed by changing the way the atoms are bonded together. So some examples might be cooking an egg, fireworks, a battery, baking a cake, if you've ever mixed vinegar and baking soda together, burning wood. So you're actually changing the composition of the materials at the particle level. So just to review, we went over this in class, but a chemical change is breaking formation of chemical bonds, where a physical change is changing those intermolecular forces, those IMFs or interactions. There is a couple instances where it could be both, or it's debated what it's classified as. Sometimes physical processes do involve the breaking of chemical bonds. Probably the biggest example of this is dissolving salt in water. You have to actually break the ionic bond to separate the compound into its ions, and then that ion dipole IMF is formed between the ions and the solvent, which is physical. So it kind of depends on who you're talking to, but just know that some changes can be argued as both physical and chemical. So let's take a look and see if we can figure out which particle diagrams represent a chemical change. So take a moment to pause the video and see if you can figure it out. All right, diagram 1 is a chemical change, diagram 2 is physical, diagram 3 is physical, and diagram 4 is chemical. So in that chemical change, we want to see those chemical bonds broken or formed. So I can see that in both diagram 1 and 4. So in diagram 1, it goes red, blue, blue, red, on this left side of the arrow, and then on the right side of the arrow I have a new connection, red, blue, red. Same thing in diagram 4, I have 2 blue atoms and 2 red atoms connected together. On the other side of the change I have 3 blue and 1 red. It is a different chemical bond arrangement. So how do we know if a physical or chemical change is occurring in the lab? There are a lot of different observations that you can make that gives you a clue about whether it's a physical change or a chemical change. And I know we're not in the lab right now, but even from the labs we did first quarter, maybe you recognize some of these changes. So I want you to take a moment to predict which ones do you think might be more of an indication of a physical change and which might be more of an indication of a chemical change, or maybe both. So in a chemical change, we're creating a new substance with a different composition. Here are some possible evidence of a chemical change. You could see the production of heat or light, formation of a new gas, formation of a precipitate, and or a color change are possible evidence for a chemical change. Where a physical change, you're changing the properties but not the composition of the substance. So you might see a change in phase. That's a very common formation of a physical change, or the formation or separation of a mixture are 2 common examples of what you might see in the lab. Typically, we say there are 4 signs of a chemical reaction, and those are production of a gas, color change, temperature change, and formation of a precipitate or a new solid. So, the four signs of a chemical reaction are: one is a temperature change or the production of heat or light. It gives off heat, it produces a light, or it gets colder. Production of a gas is another sign of a chemical reaction. We often see this as bubbles or fizzing when the reaction's happening. The third one is called the formation of a precipitate. This is when you take typically two clear liquids, and when you combine them, a new solid forms. We call this new solid a precipitate. The last one is a color change. I like to add an unexpected color change. When you mix two things together, it forms a color that you didn't expect. So you take something clear and something that's brown and it turns purple. Or you take a silver nail and you put it in a liquid and it turns green. So an unexpected color change is another sign of a chemical reaction. So again, we want to be able to identify whether a chemical reaction or chemical change is occurring at both the molecule level and the macroscopic level. And the macroscopic level is looking at these changes in the lab.